This is part 1 of the Tech and Narrative Lab's Introduction to Robotics series, where I'll be walking you through how to design, build, and code a robot using commercially available educational robotics kits, so that learners of any age or experience level can follow along at home. As we move through the concepts, we'll also be looking at the applications and implications of robotics. But before we dive into the how, let's answer these questions. What are robots? And why are they important? Robots are machines that can be used to do jobs. That's a loose definition. We don't really think of coffee makers or cars as robots, but it's hard to be more exact because robots can take on many different shapes and abilities depending on the job that they are designed for. Sometimes they resemble humans, but often they don't. Some robots can do work by themselves, some must always have a person telling them what to do. So let's look at the parts that make up a robot. Robots generally have 3 systems: mechanical, electrical, and computer. If we were talking about a human, the mechanical system would be the muscles and bones that do work in the world, like lifting, manipulating, and moving objects. The nervous system is like the electrical system that transmits signals, information about the environment and itself, to and from the brain, which is like the computer that processes all that information and makes decisions. The very first robots were purely mechanical. At the turn of the 16th century, Leonardo da Vinci built some of the first automatons, machines designed to replicate human or animal behavior using cranks, gears, pulleys, cams, and levers. Although none of da Vinci's automatons exist today, a replica of one can be seen at Chateau Clou-Lucé in France. In the following centuries, clockmakers refined these automaton to perform increasingly spectacular and complex tasks. One of the most amazing surviving examples is Maillard's automaton that could fluidly draw and write poetry, selecting from a database of dozens of works. The next great leap in robotic technology came from the father of electricity, Nikola Tesla. In one of his famous exhibitions in 1898, Tesla wowed a New York audience with model boats that seemed to operate with no visible wiring. Unlike the automatons before, the mechanisms were powered by electronics, motors, batteries, and radio controllers. Tesla called his invention a tele-automaton, but dissatisfied with its reliance on a borrowed mind through human control, Tesla conceived a future where an automaton may be contrived which will have its own mind, and by this I mean that it will be able, independent of any operator, left entirely to itself, to perform, in response to external influences affecting its sensitive organs, a great variety of acts and operations as if it had intelligence. It will be able to follow a course laid out, or to obey orders given far in advance. It will be capable of distinguishing between what it ought and what it ought not to do, and of making experiences or, otherwise stated, of recording impressions which will definitely affect its subsequent actions. He saw the possibility for these intelligent robots to become mechanical men which will do the laborious work of the human race. Tesla's prediction came true with spooky accuracy in 1948 when the invention of an electronic switching device called a transistor began a revolution in computing that would make intelligent robots possible. The first industrial robot, called Unimate, began working on a General Motors assembly line in 1961. And since then, advancements in robotic technology have enabled them to do many more jobs and with increasing skill. So what kinds of jobs are robots doing today? There are industrial manufacturing robots, humanoid and biomimetic robots, consumer, aerial, and medical robots, and new applications are being discovered every day. As computers get more advanced, so do the methods for programming robots. They're now capable of learning and updating their behavior as they do their job. allowing them to develop new and more complex skills that would be impossible with pre-programmed instructions alone. As robots become more efficient, cost-effective, and potentially more intelligent than humans at an increasingly rapid pace, serious ethical questions will inevitably arise. How will society restructure to keep up with the acceleration of technology? How much autonomy are we comfortable handing over to machines? A classic example comes out of self-driving cars, where a computer might have to decide between killing the passengers or pedestrians in an unavoidable collision. This is a variation on a moral thought experiment called the trolley problem, and there isn't a straightforward solution. There are countless questions like these that researchers, policymakers, scientists, and engineers will be faced with. One thing is for sure, having a basic understanding of how robots work will be an invaluable skill going forward. In the next video, we'll be going over the components that go into building a robot and the different ways that they move. We'll build a driving platform that we can add to later and will serve as the base for many of the lessons in this series.